Welcome back, guys. Today I'm going to solve problem number 3, coding, and we'll begin with part number 1. Write a function that counts the number of the nodes inside a tree, and also problem part number 2 and part number 3. Hopefully I can finish in this video these 3 problems, okay? So let's begin with the first one. Write a function that counts the number of the node inside a tree. So suppose I have a tree, it contains node, whatever the number of the nodes that I have inside the tree. I wanted just to count this number of the nodes. What should I do? I go left. Each time I visit a node, I add 1. It's a very easy thing. So I will begin with, if the node, if whatever I'm sending here, suppose I'm sending t, if t equal to null, then I will count nothing, so return 0. Else, so this is not null, so 1 plus, go to the left and go to the right. So suppose the function is count, the name of the function is count, go to the left, t slash left plus count t slash right. Okay, so each time I go left and each time I go right, I add 1. This is the whole idea. So it's very easy. It's like the factorial, it's like adding the elements of an array. It's like so many recursive functions we have seen even in programming 1. So this is number 1. What about find the sum of the elements? So instead of find the sum of the elements. Suppose I have here 5, I have here 4, I have here 6, and I want to find the sum of whatever elements that. Each time I visit a node, instead of count add 1, I just add what? The element inside this node. So suppose I have a node, and since inside a node I have integer value, so each time I visit this node, I add this value to whatever previous sum I have. So the same is that if t equal to null, return 0. It's the same. Else, return what? Instead of returning counting 1 here, I'm gonna return t slash, what's the name of the element here? The name is value, so I will put value, okay, plus I go to the left and I go to the right. What is the name of the function now? Instead of count, I will name it sum. So the name of the function sum, so sum slash t slash left. Also, what should I have? Plus sum t slash right. So it's the same as count, but here I have sum. That's it. Okay, let's go now to the, okay, this is the C++. Actually, you will be given something like this. Here's the name of the binary node is element. So this is the name of the binary node element. It has left and it has right. It has also a constructor and a friend class. This friend class is called binary search tree. No public function for this class. And in the private node, I have only the root. Okay. So in order to preserve security, I will not allow any public function to access the root. In order to do so, I will create a helper function here as a private function. These private functions can access the root, and I will create a public function. These public functions can access the private functions. Okay, so integer count, this is the first count, and it will take nothing. It will return what? Count, but I can name it count, I can name it whatever I want to name it. So in order, I will name it COT, not count, coat. I will name it whatever you want. Okay, this is the whole idea. So I will name it COT, and this will take what? The root. Okay, this is a public function that I'm going to call it from the main function. Now inside the private, I will implement this one here. So this one, it will integer COT, this is the name of it. Okay, so it will take binary node, and I will name it star t. You can name it whatever you want. I will name it tree. You know something? Let me name it a tree. Okay, so this code will do what? If tree, sorry, if tree equal to null, then return 0. Else return what? Remember, this is 1 plus COT. This is the name of the function. Now I'm sending what? T slash left slash, this is slash, what's going on? This is slash, sorry guys, plus COT T, not T, it's a 3. It's a 3. Okay, be careful, it's a 3 now, slash right. Okay, and that's it. This is the end of the function count. When I call count, I will call this count without sending any parameter. This count will call another function, is called quote, and this quote, whatever, will call this function here as a private function and will return 0 if tree equal null, and will count the number of the nodes. Okay, what if I want to implement the function sum now? The same thing. I'm gonna copy this and paste it here, and instead of count I will name it sum, and here also I will name it sum. As you know, we can name it whatever we want. Okay, I have sent root here because the name of this one is root. Of this root, suppose x, I'm gonna send root x above, you know, all this stuff, and the same thing will happen here. So here, this one here, control C, also control V, and instead of this one I will name it sum, and if tree equal to null I will name it forget about it, let it be tree, return. So here, instead of what's called, it's called tree slash, I will go back here and see what I have named it. Look guys, its name is element now. Here it's element, so I go back and write here element. So tree return tree plus element plus, instead of this is sum here, it's the same, and here we have also sum. Okay, so suppose this is the implementation of the sum function. Nothing, it's still the same. Suppose I want to implement now the average. Okay, so the average is equal to the sum divided by count. Okay, so double average return, look how easy it is. Double, I'm casting now, you know, from programming 1, sum, I'm sending to the sum root, divided by count, sorry, it's not count, it's quote. Now I'm sending to it what? Root. And that's it. I have implemented the function here, average. So hope you have enjoyed this tutorial. See you in the next tutorial. Bye.